This is the next video, and we'll put some numbers on these. We're looking at transforming a whole section. In other words, a whole cross section rotating about the x-axis 90 degrees. Positive. So let's see if I can find the eraser in this handy dandy little thing here. There's an eraser. So I'm going to get rid of right now. That's the soft eraser. This is Cam Studio. I'm sorry, Smooth Draw. One of my recommendations, and again, you don't have to take any of my recommendations. This is freeware. This is what Sal uses, and so I got a little bit of Sal worship thing going on here, but kind of like the Intel commercials. My heroes might be a little different when I'm trying to get everyone, my kids, my students, to kind of play to this higher level or lower level, if the case may be. So if you haven't seen Intel commercials are nothing but fun. Alright, so if you remember, we came up the last time with a positive 90 rotation matrix about the x-axis by this, starting with a unity matrix with a 1 stack here for scale. These, of course, will be for your translation. This is going to be for scale about any axis and also for rotations. We then plugged in cosine minus sine, sine cosine to the part of the matrix that's not the fixed axis. So we took these, remember we kept these constant and these constant, and we plugged in the minus the sine of 90 degrees. The sine of 90 degrees is 1, if you remember from your unit circle, and we plugged in this, multiplied by the single point, and we got this transformed. 5 times 0 is 5, minus 3 times 0 is 0, 0 times 0 is 0, 1 times 0 is 0. We add all those together to get to 5. Do the same thing here to get 0. We do the same thing here in the third row, 1 column, to get minus 3. And that, in fact, is what we would expect if we rotated this down so that we've kind of put the ditch where the ditch needs to be. What I'm going to show you now, using my handy dandy erase, is that you can use this to multiply and transform a whole section. So 4 points, 6 points, 1,000 points. And this is what you would have done in Wolfpack. So you might want to go back and look at it there. I will tell you that this is going to be more durable to do it this way, so I'm going to get rid of this. And what we'll do is we're just going to stack up, in this case, our vectors as kind of single columns with a padding of 0 down below. So if I go back to my pen here, I think that's a 2D pencil. This actually, you'll see if this works. We're going to multiply this matrix by our entire matrix. And what we'll do is we'll plug this in a calculator. We'll have to do this in class, or else have it take the time to plug this in a calculator here and multiply. Remember, you're taking the transformation matrix by the matrix of points. You can't do it the other way around. Matrix algebra is not like regular algebra. It's not communicative. I don't know when you can't flip them around. So here's what we'll do. We'll put all our points in a row going left to right, typically is how we do it. So we have minus 12, minus 3, 0, and 0 for this first point, minus 6, minus 2, 0, and 0 for this point, 0, 0, 0. Remember, these are just placeholders. Get used to placeholders in mathematics. 5, minus 3, 0, and 0, and 10, 3, 0, and 0. And when we are done, we should know that this is going to all turn out to have the same x's, but the z's are going to be different. So this is going to be all shifted down 1. And you'll see this is really not, you could do it by math pretty easily. However, we're not always going to be rotating 90 degrees. We're not always going to be rotating 90 degrees, especially when we start rotating about the z or the yaw. Remember, what we're doing here is doing a roll. Roll is a rotation about the x-axis. And again, remember, on this one we're going x and then z up out of the page. We start talking about some of these. Now, that doesn't necessarily make sense when we talk about these things, but really we're drafting on a flat XY plane. All right, so let's see here how we go about doing that in a calculator. And I'm just going to do the explanation on the calculator. What you're going to do is, let me erase this out over here. You're going to go to, I'm looking down at my calculator, you're going to go to second matrix, and then you're going to edit A, and you're going to make it the transformation matrix. All right, so you're going to plug in, and it's going to be a 4 by 4. And you're going to plug in these numbers. Later on, of course, you can put in some little programming so it can do all this for you, but I'm going to tell you, it's probably not worth it. It's worth doing this for quite a while. We're going to use Wolfram Alpha, you'll see, to multiply these matrices as well. You can always guess that you're going to use Wolfram Alpha for math. And then you're going to edit B, matrix B is your set of points. And they are stacked. Remember, they're stacked, coming down X, Y, and Z. And then you're going to get out and just multiply A times B, not B times A. And that, if you're smart, you'll put it into C. So you actually have the output stored. And that will do your transformation. That will do your transformation. So we're going to try to do this right now. I'm going to pause this. And if I can write the stuff on the side, I'm going to actually plug it right through in the calculator on the screen here. So hang on, we'll see if we can take this down. All right, this is too sweet just to see this calculator on top of Smooth Draw. So we'll talk about how those of you who want to make your own notes can do this. So I'm going to have to turn it on. And what you remember I said we're going to do is we're going to plug this matrix in A and this matrix in B. How do we do that? We hit second matrix. We go to edit A. A is going to be a 4 by 4. And you notice here I've only got my mode set to singles, which we really want to make to one digit. But we're going to go ahead 1, hit enter, 0, 0, 0, 0. Go back to there, 0, 0, minus 1. Remember, you can't use the subtract, you got to use the minus 1, 0, 0, 1, 0, 0, and finally across the bottom our placeholder 0, 0, 0, and 1. You can hit second quit. Now you have stacked up. If you want to look at that and check it, second matrix A, that's what the matrix looks like. Now you go to second matrix B, and this will be a little bit more difficult. B, there's nothing there. Quit. You want to go second matrix edit. Again, Wolfram Alpha, or maybe in the Excel you use this summer if you're taking that course. I'll really show you how to do it in Excel, and more so, I'm hitting an enter here. Enter. Now, if you remember, we had minus 12 for our, go back here, minus 12. The next one was minus 6. The next one was 0. That was our center point. The next one was 5. And if you notice this, 1, 2, 3, 4, this should be a 4 by 5, so I can still go back here, second quit, second matrix, edit, B, which we never did because I quit, didn't save. I want to have 4 rows and 5 columns because I have 5 points. This number can go up to 1,000. Now you're not in this calculator, but you can do it because you can stack up a lot of points. That's what you're doing when you're using Wolfpack. Let me try it again so I don't run out of time. Minus 12, enter. Minus 6, enter. 0, enter, 5, enter, 10, enter. It should jump you back to the other one, -3, enter, -2, enter, 0, enter, -3, enter, and then 3. In other words, back above the ground. Once I've got that, I can hit second quit. Now if I look at my second matrix B, you see B is exactly as I stacked it. Now your final bit is to do second matrix A times second matrix B and stow it or store it into second matrix C, which you don't always need to do. Hit the calculation and we'll see what we got. Now when you look at this, something is off, and that will probably be, when you look at this number here, there's some multiplication that we have wrong. If we see that 162, 84, 0, this one should just be rotating about that 90 axis. So we probably stacked something wrong within here. Let's go back and look at it. That's why you go to second matrix. Let's go to that matrix there, the A one. -12. That's matrix A. So as I did that, somehow I plugged those in wrong. That's why you got your multiplication. If you remember what that was supposed to be, that was 1, 0, and 0. Okay, so somehow when I was plugging my numbers in, 1, 0, 0, and we'll check again. Alright, so that is right. Now if we go A times B, it should work. Second quick, second matrix A times second matrix B. The B is of course the points, the A is a transformation matrix. Stow into second matrix C. Hit an enter and you see you have what you would expect. -12, 0, -3, -6, 0, -2, 0, 0, 0, 5, 0, -3, and 10, 0, 3. Once again, that number here was probably mispunched. So you want to make sure that when you do this, you do it on a shape you know the answer to. Let's check what matrix B looked like. Second matrix B. And if you look at second matrix B, that last one I had 10 and 3, so 10 over 3, and so as I shift this thing down, yeah, that in fact is correct. It should be +3. So when I go to second matrix C, that last number is in fact a +3. Alright, so that is how you rotate. Use a calculator, and realistically we're going to use a lot of spreadsheets with this, and Wolfram Alpha, when you're stacking up 1,000 points, the calculator can get a little bit odd. But what I want to point you out here is that we're doing this on a W, on Cassiopeia. We're transforming something about its x-axis, so the x-axis, so you can flip it down into the plane. So you can flip it from being a horizontal plane into a vertical plane. That's what we do with typical sections a lot. And then the next thing we're going to do is we're going to learn to rotate it about the z-axis, yaw. That's going to be basically a negative rotation because you put your thumb up the z-axis and you wanted to turn this. If you're going to go turning it right, let's say you're making a right turn, we're going to use a negative rotation, and we'll see how that works. Remember, finally, in your brain, if you can think, cosine minus sine, sine, cosine works for x or z rotations about the x or z axis, and then you have to flip the signs here for y, and we'll try to investigate why the math works out that way. Thanks for listening.